Would it be 0.5 over 0? Would that be a point?
Over 0?
Or comma 0?
Comma 0. Okay, yeah. So the x-intercept would be 0.5 comma 0. Okay.
For B, would you just pick like if it's negative or positive?
Basically, that's what a greater than 0 or a less than 0 means.
Okay. Would it be negative less than?
Well, in this kind of problem, this is linear, right?
Right.
Yeah.
So linear is going to look like ax plus b, so to speak. So this is our slope. So is our slope positive or negative?
It'd be positive.
Positive, because it's going up to the right. Does that make sense?
Mm-hmm.
Yeah, like if I have to start, always start your person on the left and I have to walk up.
Okay. Right.
So that's positive. So this would be a is greater than 0. That's positive. All right. And then for C, what's the minimum degree of the function?
I didn't get this one. I was kind of confused on C.
Okay. Did anyone else get minimum function of f that could explain it?
It's a linear function, teacher, here, right?
So what's the minimum degree? And could someone explain it?
I want to say it's 0.
I put 1.
1. We have a 1 and a 0.
I'm not sure if I'm right though.
I just kind of got a degree of n from the notes.
Oh, of
I
n.
got 1 because there's no turning points.
1 because there's no turning points. So how'd you get 1? Like, how do you go from there are no turning points to it's a 1? Like,
Because in the notes it said however many turning points there are, you add 1, and that's the degree.
there we go. Does that help a little bit, Fidel?
Mm-hmm.
Yeah. So however many turning points there are, you add 1.
Right.
So this one has no turning points. So that means it's minimum degree of 1. So what if it had like 16 turning points? What would the minimum degree be?
17.
17. Cool. All right. Well, thanks for that one, Fidel. Let's go to Jade for number 5.
Teacher, please, here our x-intercept is 0.5 and we have 1 point, right?
It's 0.5 comma 0 is the x-intercept.
We have only 1 point here because it's just,
Exactly. That's correct. Only 1 point. Yeah.
okay.
All right, Jade.
You said me for number 5.
Yes, for number 5.
Okay, so the turning point, like, that's like when it's ever like, whenever it's like going, say, like up and then it ends up turning and going down, right? Turning point. Okay, so
you were walking this and it was like uphill and then it went down. That's a turning point. Yeah.
So for number 5, I can't tell exactly what the x is because it's not -4, -5 maybe.
Yeah, maybe like -4.5. Maybe
Okay, yeah.
a little bit, something like that. Close
I
enough.
couldn't tell because it's like in between the in between, you know what
I know, that's why I was saying maybe -4 point.
Yeah.
I mean, you could maybe do like -4.8, maybe 4.7. I don't know. It's close enough. Okay, what about the next one?
-1.
-1 comma 0. We always write it as a point.
Yeah. And then 4 comma 0.
I don't think that's 4 actually, because 4 is here. So.
No, okay, we're talking not okay. So.
Oh wait, no, you're talking turning point. Yeah, so it is 4, but this isn't 0 up
You
here.
put 0 after 4.5 and it didn't really look
Oh,
like.
you're right. You're right. I don't know why I put the 0.
You were putting 0, so I was confused.
I was thinking of x-intercept, so that one's a 2.
Okay, I was like, is the turning point just x?
No, my brain went to x-intercepts already. Okay, so 4 comma.
It kind of looks like 5.
Yeah, I would think that's 5.
Okay, I was like almost right below it, but not really.
So these are the turning points. And then we still have to do the x-intercepts, which is where my brain went to a little earlier.
Yeah. Are we doing x-intercepts now?
That's part of A, yeah.
So then -5.
I think it's further than 5 because 5 would be half.
Oh wait, it'd be -6. Sorry, I forgot they're going to.
-6 here is the 0 that I kept putting.
And then it wouldn't be like that middle dip, right? Because it doesn't actually cross it.
It doesn't have to cross it, it just touches it.
Okay, so then -1
Okay.
and 6. Sorry, I missed the 5 again.
That's okay. So these are our x-intercepts. Okay. So let's talk about multiplicity a little bit because that was in the video. So for our x-intercepts, what would our multiplicity be? Do you remember that from the video at all?
No.
1.
So multiplicity has to do with whether it crosses through or whether it bounces. So if it crosses through, it has an odd multiplicity. So if we're looking for the lowest possible multiplicity, then this one would have a multiplicity of 1, but it's odd. So it could be 1 or 3 or 5 or 7, all the odds. Now, when it bounces, that means it has an even number of multiplicities. So this could have a 2 or a 4 or 6 or 8 or whatever. But the lowest would be 2. So what about our last x-intercept? What's our lowest multiplicity for that one?
I'm not sure.
It goes through it.
So 1.
1, right?
Okay.
Am I saying that incorrect, Professor Sievers? You look like you're shaking your head. No? Okay, you're looking at something else. It has nothing to do with it. All right, got it.
Teacher, here you confused me.
Multiplicity, so if it bounces on the x-axis, then that means it has an even multiplicity. So it could be squared or to the 4th power or to the 6th power. If it goes through the x-axis, then it has an odd multiplicity. So 1 exponent or 3 or 5 or 7, something odd.
But in this graph,
What about it in the graph?
yeah, in the graph for the number 5, the graph number 5, the multiplicity is in the -1 because it
Well-
touched twice.
Now, multiplicity has to do with the x-intercepts. So the multiplicity for the first x-intercept, which is -6, 0, that the lowest multiplicity that could have is a 1 because it goes through. So if it goes through, then it has an odd multiplicity. So I guess I could just write odd multiplicity instead of 1 if that's getting confusing for you. This one has an odd multiplicity. And if it bounces, like the next intercept is -1, 0, that one bounces. So that one has an even multiplicity. So it could be squared or to the 4th power or to the 6th power, something even for the exponent. And that was in the video. So I just wanted to mention it because you might need to know it at some point, especially with your test coming up Thursday, you might need it. Just wanted to make sure I mentioned it. Okay. All right, we can continue on to B unless someone has questions on the multiplicity part. Anyone have questions on multiplicity? Okay, all right. So Jade, I think we're still going for B. Is it going to be A is greater than 0 or A is less than 0?
Greater than?
So this one looks like a sad face, right?
Oh, less than then?
Yeah, looks like a sad face, so it's less than. Whenever both the tails match, you want to look at it like a happy face or a sad face. You know?
Happy face is greater than sad face. Okay, thank you.
They match. So this is greater, or sorry, less, you're right. My brain just went with what you were saying about happy face. All right, C, determine the minimum degree.
I have no idea how to be honest.
Well, Fidel can help you with this one.
Okay.
Right? What's the minimum degree here, Fidel?
This is number 5C.
Yeah,
Okay.
Would it just be let's see here.
we just did this before with the 16, right? Or I made up one, it said 16.
Oh, would it be 0?
How many turning points do we have?
Oh, we have 3.
Okay, so what's the
So it'd
minimum?
be
degree?
4.
4, okay. So what we do is we take the turning points and you add 1.
Okay.
So if there's 3 turning points, it's a minimum degree of 4.
Perfect.
All right, who's next? Joshua, you're next. Number 7. Write it over here. Hopefully I can fit it. There's a lot of things happening on this one.
So I got that there were 4 turning points.
Okay. Should we write them out so people know where they are?
So I didn't write them down, so I gotta look at the graph, but
It's good practice for reading these graphs.
looks like -2.5, comma 3.
Okay, 2.5 comma 3.
And then -1/2, -1/4 maybe,
Yeah, that looks like a quarter, 0.25. Okay.
and then 1/2, comma 1/4.
Okay.
And then it'd be 1.5, -1/2.
Okay. And that's it, right? So 4 turning points?
Yeah.
Okay, awesome. 4. And then x-intercepts?
They were -3, 0.
Okay. And is that one, what kind of multiplicity is that one gonna have?
It's odd here, right?
It goes through it. So it's gonna have
Yes.
multiplicity of an odd exponent. So like a 1 or 3 or 5.
Yeah, I'm not 100% on the multiplicity thing, but
So if it goes through the x-axis, like look at what's happening to it. Like if you follow it, so I'm going along my graph and look, it cuts through it. See how it's going
Right.
through? That means it's gonna have an odd multiplicity. So it's gonna have a 1 or 3 or 5 or 7 as an exponent. So it's gonna be an
Okay.
odd multiplicity. Okay. And if it doesn't, if it bounces like on Jade's problem over here, see how it bounced? It didn't cut through it. It like bounced back up.
right.
Then that's an even multiplicity.
Okay.
Okay, let's go to the next one. Next x-intercept.
Is -1, 0.
Okay. And that one's odd multiplicity, right?
Right.
That cuts through.
And then 0, 0.
Uh-huh.
And then 1, 0.
Mhm.
And 2, 0.
Nice. And these are all odd multiplicities on this one because every time it's cutting through every single time. All right. And then B. Sorry, A. Greater than 0, less than 0.
A is greater than 0.
Oh, good. And then C, minimum degree.
It's 5.
Okay, good. Awesome. Any questions on that one?
Here's the leading coefficient is positive, right?
A is greater than 0 for B, if that's what you're asking about.
Yeah, it's positive, yeah.
Mhm.
Okay.
All right. Yeah. Any questions before I erase it? Questions? No? Everyone's so quiet today. Does that mean you're all get it and you're all gonna ace it 100%? You're all so quiet. Okay, I'm gonna assume that's what it means since no one's saying anything one way or the other. Okay, so we are cutting these out. Woohoo! So we're gonna move on to 55. And that's the next section y'all are gonna go practice. So you should have graph paper, or you can kind of sketch a little mini graph if you want. Your graphs don't have to be perfect here because the directions say sketch, but it does need to hit the key points for the problem. Okay. All right, so let's go back to groups. Let me type in the chat which ones we're doing. So we're at 55. So
Yeah, I will try because
okay, I can use a different color next time if the red is difficult for you to zoom in on. Let me know.
okay, thank you.
So what's the multiplicity of that 0, y'all? What's the multiplicity? We're all so quiet. I'm gonna make us all do something embarrassing. We're all gonna have to like share a
Don't
fact or
know.
something if no one wants to
One.
talk.
I was gonna say 1.
Yeah, it's a 1. It's something odd, right? So like 1, 3, 5, something odd. Yeah. Okay. I know. I'm gonna have everyone like share something embarrassing if no one wants to talk. Make everyone talk. All right, so we're gonna go do 87, and I believe 93 is also assigned. Yep, 87, 93. These are gonna take a bit more time because they're piecewise. So you're probably gonna need a table for these.
I'm still solving 93.
93, okay. And Alondra's the only one who did it.
It was
Oh, it's-
87 and 93.
Yes, 87 and 93.
Yeah, I only got 87.
Okay, so we'll probably have to go back to groups then if no one did 93.
Working on it.
Okay, so let's see. Next is Fernanda. So Fernanda, can you help with 87? And then we'll go back to groups to keep working on 93.
I was really confused on these. Like, I don't remember. Like, I didn't really remember them. So,
Ooh, gotta go back and review. Test is Thursday. Let's
Yeah.
see. Is there anyone who does feel comfortable with these that can help?
I don't feel comfortable, but I would like to give it a try since I kind of don't know, but I can let you know where I started at, started from.
Sure.
Okay, the first thing that I did was what I kind of looked back at the notes and it was a similar problem like that. But what I ended up doing was like for the 4 minus x squared, I end up doing plugging in -3 for the x.
Okay.
Right, because I know earlier you was like make a table. I was like, I don't know what you're talking
It
about.
might help. Yeah. Yeah, for sure.
Okay, and then when I, did the 4 minus -3 squared, I ended up getting 5. So I had got -3, -5.
Okay.
Right?
Yep. That looks good.
Okay. Woo. Then the second one was for the 0. And like the 4 minus 0 squared, and I end up getting 4. Like on my table, I end up getting 0,4.
Okay. What about all the stuff in between?
See, I thought I just needed. See, okay.
Well, I mean, if you just have those 0, 1, 2, 3, 4, if you just have those, you don't know what it looks like in between. Right? Look, I just graphed the 2 points and now I don't know. Is it like that? Right? Like I don't know for sure what it looks like in between. I mean, it's a parabola, so I would assume it's going to have a parabola type curve, but does it curve like this? Does it curve like this? Like that's why I would plug in some more points in between if you're not sure, rather than get it wrong.
Okay, but how do you determine or how do you choose what points?
Whole numbers are nice.
So no, I'm just saying so we could put in our own numbers.
Yeah, I would go with whole numbers. I would not do decimals because that doesn't sound fun, and fractions don't sound fun either. So I'd probably just plug in -2 and -1.
I was thinking that, but then I was like, I was just kind of looking at that formula, so I was kind of like, oh, but okay.
It's okay. So that's what I would do, and then I would have 4 points, so that makes it pretty handy.
Yes.
Oh wait, that's a filled in dot. I missed that. Let me fill that in instead of making it open. That one's filled in. 2, 3, 4 filled in. All right, so -2 zeros, good, and then -1, 1, 2, 3. All right, see now I can tell. Okay, it's probably a curve more like this, right? It's a little bit easier to see. Now, if you're really comfortable with your parent functions, you can look at that and say, okay, and your transformations, you can say, okay, it's negative in front, which means it was flipped over. And then the 4 means we moved it up 4. So if you're really familiar with those, and you could kind of see that. All right, what about the second part? I'll put the second graph or the second table over here for this problem.
The
See,
first part, excuse me, the first part, teacher, is the half of parabola, right?
Yep, half a parabola.
Yeah, okay, perfect, thank you.
and the second part, I was kind of talking with my group, and that part we got confused on.
Well, we're gonna do the same process, right?
Okay.
I'm just making another table. I'm gonna start at 0, but I'm gonna put a little note here that's gonna remind me not equal. So that has to be an open circle. Just a reminder, that's gotta be an open circle. So at 0, -4, that has to be an open circle. Because I need to know where to start. So 1, 2, 3, 4. So that's an open circle right there.
Okay.
And then I would do the same thing as before, just plug in some numbers all the way up till 3, so we could see what it looks like. So maybe 1, 2, 3 to get a couple points.
And then for that 3, I know that's a comma 5. Because okay,
Yep,
yes.
3, 5.
Okay, yeah, okay. So I kind of see what I did. I just didn't plug in those missing numbers.
Yeah, because otherwise you can't really totally see what it looks like in between. So gotta have those points in between.
Oh shit.
So I think this is -3 and this is 0. So 1, -3, 2, 0.
3, 5.
There we go. Yep. And then connect them up. And there you go. There's your piecewise function. Everybody needs to be very familiar with your piecewise functions by Thursday. If you're one of the people who looked at this and said, I don't know how to do it, you need to go back and review before Thursday.
Okay, and you said it's called the piecewise?
Piecewise, yep. All right, what about part B? Is this continuous? Is this continuous?
No, it's not.
It's not continuous. There's a break in the graph, right?
Yeah,
Yes.
Everyone sees like right here, there's this big break, this big jump. So it's not continuous. Continuous means that you can follow from one side all the way to the other side without having to pick up your pencil. Or it's just like a continuous thing, like a river or a road or something. This one has this big break in between. So you're all right. Not continuous. Okay, what about part C? Can someone solve that? F of x equals 0?
Yeah. Can I do it?
Sure.
Thank you. Here I took the function of x squared minus 4 equals to 0 because it's between 0 and yeah. I put f of x equals to 0, which is x squared minus 4 equals to 0, and then x equals to plus minus squared 4, and which is plus minus 2.
Okay, so you got plus or minus 2 for x?
Yes. One x equals to 2, another x equals to minus 2. And my point here is 2, 0, another point is minus 2, 0.
Yep, that looks good, but you didn't have to plug it in if you didn't want to, but plugging it in is great. You could look at the graph because we already plugged it in technically, right?
Yeah. I just wrote them like as a point because my y equals to 0 and it's like an y-intercepting. Yeah.
Yep. Yeah, but we can also see it in our table. That's where y is 0, and this is where y is 0. We can also see it on our graph.
Yep.
So there's a lot of ways to do it, or you could do what Ganya did, which is plug it in. You can make the y 0 and solve both of them. So there's 3 ways you could have done that. Okay. Any questions on that one before we go back to our groups to do 93?
Yes, I have a question. I couldn't really hear her when she was explaining it, where and how you said that you could plug it in to see what it is?
Yeah, so since when I look at my graph, I can kind of tell that 0 works as a y, it works for both of them. So what she did is she just plugged it in for y like this, and then she solved. So she subtracted 4 on both sides, divided by -1, and then took the square root. And that's how she was getting the plus or minus 2. But you can do it for both of them, you get the same thing. Oh, not
Okay.
square root. Sorry, you gotta get rid of the square root. I used it. Plus or minus 2. There we go.
Okay, because yeah, I just didn't hear what she had plugged in, so that's why I didn't understand. Like, how did you get that? But okay, gotcha.
Now for the left function, it only would be the -2. And then to get the +2, technically you'd have to plug it into the right function as well. Because both of those, this is the spot for the left function that is 0, and this is the spot for the right function that is 0. So you technically would need to do both. It just so happened that they're both 2, right? -2 and +2. Just so
Okay.
happened. But what if one of them had been 3? Then it wouldn't work. So you want to make sure you're plugging it into both if both of them can have a y of 0.
Okay, gotcha.
Okay. All right, any other questions before we do 93? Groups. All right, let's go back. I'll give you like 5 minutes to work on it in groups. All right, here we go. Probably the last one for today, since we only have a couple minutes left. So let's see. Let me pick somebody to work on it since, oh, there's a lot of videos off. I hope y'all are here. Hope you're not missing stuff. Remember, you're paying for this class. You want to be here to learn. Let's see. Let's have, how about Joshua? Can you go through it? This one
Yeah,
has
so
3 parts, huh?
I'm gonna just list off the points I got.
Yeah, that's good. That way people can follow. We want to make sure everyone can follow what's happening.
Okay, so the first one was -5, -10.
Okay.
And then -4, -8,
Okay.
-3, -6,
Okay.
and -2, -4,
All right.
and then -1, -2.
Okay. And you should have some sort of note over here there saying it's an open circle. Because
Right.
it's not really a point. It's like a point to guide us, but it's not really a point. Okay.
And then for the next one, it was also -1, -2. So I just kept that circle closed.
Oh, so it does end up being a point. Awesome. Okay.
Yeah.
And then,
And then
0.
0, -2.
And again, that one's supposed to be open unless it happens to be the same as the next one. Okay.
Right. And it does end up being the same.
Oh, okay. Nice.
And then you get 1, -1,
Okay.
and then 2, 2.
Awesome. All right, let's throw it on the graph. 2, 4, 5, and I think -10's all the way down there. I know we're short on time, so I'm not counting. I'm pretty sure that's -10 though. Pretty sure -8's there. We go all the way to -1, so one more. Okay. So that's the first one. And again, it would have been open, except it happens to be the same as the next one. Is this what yours looks like, Joshua?
Yes.
Okay. And then that one gets curvier because that one's a parabola. Okay, so it's a line, a horizontal line, and then a parabola. Gets kind of curvy on the side.
Yes.
All right, okay, B, continuous or not continuous?
It is continuous.
Yep,
Yes.
good. You don't have to stop as you're walking along the path, it all connects. All right, and then f of x is 0, so what's x?
Square root of 2.
Is it square root of 2?
Yes, plus minus.
Is it? When y is 0, oh yeah, we're gonna have to actually solve it, because if you look at our graph, it's here, but we have no idea what decimal that is, right? And we don't want to guess. We actually have the function, so we need to find it. So which function am I going to use? The first piece, the second piece, or the third piece?
X squared minus 2.
The third piece, right? Because this is the third piece.
Yeah.
This is our third graph, our third graph or table that we're using. So we're going to use the third one. So x squared minus 2 equals 0. And I think Joshua already said that it's going to be square root of 2. And why is it not plus or minus square root of 2?
Because it's not positive, it's negative.
It's negative?
No, because x squared equals to 2.
Uh-huh. Why are we not writing plus or minus 2?
Yes, we need to write it.
We don't write plus or minus 2. Why?
X squared equals to 2, which is...
Because they could be different.
Well, minus radical 2 is over here, right? Is our graph over there?
No.
No, so that's not a solution to this problem. That's out of the range of that graph. So only the positive rad 2 is actually in that table. The negative rad 2 would be outside the given domain for that piece. That piece is 0 to 2, and the negative rad 2 would not be part of that. It'd be outside. It'd be part of a different section. That's why we're only doing the positive instead of plus or minus for this one. Okay. All right, so y'all have 2 to do from the book, 2 left. Remember, answers are in the back, and then you have your actual graded problems to complete. And I know we are out of time, so if y'all have any questions, you can kind of let me know real fast, but we are out of time for today.
Okay, I have a question. I know like some of the problems that we do, like the answer is in the book. I know like at the beginning of class we have additional copy, but I have a hard copy myself, and I was trying to check my answers, like, you know, to look in the book, like, you know, to make sure I'm doing the right thing. I don't understand how to get the answer like in the book.
It should
like,
be in the book. I mean, I have the virtual copy. We just go to the back of the book and then we look for the problem.
I'm talking about like for an example, like on the graded problems, you know how at the top of the page it say check answer starting on page A21.
Yeah, that's for the textbook ones. That's not the graded ones. The graded ones, we post the answer key. Those are our questions.
Oh.
The book has answers for the book questions, not the graded questions.
Okay. So, okay, gotcha.
No, go ahead.
All right. I know class is over. Any last minute questions?
Please, just a quick question. Here, our domain for this function is minus 5, 2, right?
Yeah, but it's for each piece. So yeah.
But if we did the domain for the whole function, the domain here is minus 5, 2, right? Okay, I want to just make sure. Okay.
Yeah, no, you're right. You're right. It's just that negative radical 2 would have not been part of the part that we're looking at, right? The line itself, -5 to -1, that does not have a y-intercept. So that's why that didn't count. Yeah.
Okay. Thanks so much, everybody. See you tomorrow.
See you tomorrow.
Thank you. Bye-bye. Have a good